Welcome, geometry students. Today we're going to learn how to write and analyze conditional statements and write algebraic proofs. So first of all, what is a conditional statement? Well, a conditional statement is a logical statement with two parts. And those two parts are a hypothesis and the conclusion. So essentially our hypothesis is just like what we think of in science. It's what we predict will happen, and then our conclusion is what outcome actually occurs as a result of that statement. So when we write conditional statements in geometry, we're going to write them in what's called if-then form. So essentially it's just a statement that we begin with the if, and the if is really just going to be the hypothesis, or the setup of the situation, and then the second part is the then. And the then is the conclusion that we can make based upon what happened in the hypothesis. So you're going to find this year that your theorems, your definitions, much of what we work with is going to be set up in if-then form. Example 1 says to write the conditional statement in if-then form. The statement says, I won't come over if we are watching Keeping Up with the Kardashians. So what we need to decide first of all is what's the if and what's the conclusion. Well, in this case, the if or the hypothesis is if we're watching, and if you notice it has the word if we're watching Keeping Up with the Kardashians. Now, it won't always use the word if in the sentence, so then you need to decide what is going to be dependent on the other event occurring. In this case, basically what we're saying is if we're watching Keeping Up with the Kardashians, then what outcome is going to happen? Well, in this case, we're claiming if that occurs, then I won't come over. So then, I won't come over. So I've taken the original conditional statement and I've put it into if-then form. Keep in mind, you're always going to begin with your hypothesis, and that goes in the if. We're going to follow that by a comma. So once our hypothesis is done, we're going to put a comma and then write the word then. And this is the conclusion that's going to happen because of that. Example 2 says identify the hypothesis and conclusion of the conditional statement. Then negate the statement. We'll talk about what this word means in a minute. Well, we know the if is the hypothesis. So the hypothesis is this piece right here until that comma, and the conclusion is what is in the then piece. So that is the conclusion we can make. So in this case, it sets it up that if this month is July, then the next month is August. So our hypothesis is that this is the month of July. If that's true, then we can conclude that the next month is August. Keep in mind, the conclusion depends on the hypothesis being true. Okay, so we've identified the hypothesis and the conclusion. Now we're going to talk about this negate. Negate means to make it essentially the opposite. So if this month is July, the opposite of that would be if this month is not July. Now, the key is when we make the negation, we don't just negate the hypothesis, we have to also negate the conclusion to keep it consistent. Then, the next month is not August. So when it's asking us to negate, we're going to do that to both the hypothesis and the conclusion. Example 3 says to rewrite this statement in the given form below. Then decide if each statement is true or false. So first of all, we have a statement. Olympians are athletes. We're going to take that and put that in if-then form. So we're going to include some more words to be a little more specific. So if, we don't want to just put if Olympian, we want to put if you are an Olympian, then you are an athlete. Well, ask yourself if that's true. If you are an Olympian, then you are an athlete. Yes, if you are an Olympian, you are actually a very good athlete. So that is true. Converse is like the reverse. It's where we switch the if with the then. So we're just going to simply make a switch of the if and then. Well, our initial if-then statement is located right here. So we're just going to switch the if with the then. So we're going to start here, and we're going to say if you are an athlete, then you are an Olympian. Well, if we decide if this is true or false, we can think about it this way. Are all athletes going to go to the Olympics? No, that's not true, because some athletes are very good, but they may not be good enough to be at the Olympics. So this would be a false statement when we look at the converse. The inverse is where we negate. Keep in mind, negate is really just like the opposite. So this is where we're going to insert the word not into our if and then. So if we look at this, our original if-then statement, we're always going to come back to that, so we're not coming back to the converse. Our original if-then statement said, if you are an Olympian. So we're going to say, if you are not an Olympian, then you are not, keep in mind the not goes in both places, the if and the then, an athlete. Well, if you are not an Olympian, that doesn't mean I'm not an athlete. I might still be an athlete, but again, I may not be good enough to go on to be in the Olympics. So that is false. Contrapositive does both of what the inverse and converse does. So it reverses, and negates the statement. So essentially, I'm combining the converse and the inverse into one statement, and that makes the contrapositive. So if I reverse it, if you are an athlete, but we're going to put in the negation. So if you are not an athlete, then you are not an Olympian. Well, if you're not an athlete, then you wouldn't be good enough to go on and be a famous athlete in the Olympics. So that is true. Last one is a biconditional. This is going to include the phrase if and only if. Now this is the most unusual of all of them, meaning it doesn't quite fit in with the rest. This is not going to be an if-then form. Instead, it's going to put the if and only if in the middle of the statement. So we're going to say you are an Olympian. Here's the if and only if part. If and only if you are an athlete. Now the reason why this one doesn't suit to the rest is the first four are a lot more similar. They're an if-then form, whereas biconditional statements are not. They're going to have the if and only if statement in the middle. The other thing about the if-then statements, the first four that we discussed, is that those are not necessarily reversible, meaning if you were to reverse, that doesn't necessarily make the statement true. For example, we saw this statement to be true, but its converse was not. At biconditionals, if we look at a biconditional, we can always reverse it, and the reverse or the converse will always be true. So that's something unique to a biconditional. So converse is also true, assuming the original statement was true. So you might be wondering why we're doing so much writing today. And the big idea of today is really just to set up an idea of what's to come with the definitions that we're going to be seeing. If you don't understand the parts of an if-then statement, it's going to be hard when you see a geometry term in if-then statement. So we're not really doing a lot of what appears to be geometry today. We're doing a lot more writing, but like I said, it's just to kind of get us to understand the different parts of our definitions that are going to be coming up soon. For example, this is a perpendicular line definition. It starts with if, so there is our hypothesis. If two lines intersect to form a right angle, then here's the conclusion we can make, then the lines are perpendicular. And the symbol for perpendicular is an upside down capital T. At least that's what it looks like. So the big idea is this. When we look at our if-then statements for definitions and so forth and everything else we look at this year, the if is what's required to happen. So if that occurs, then the conclusion is that those lines are perpendicular. Another word that we need to know is linear pair. A linear pair is a pair of adjacent supplementary angles. In other words, a pair of angles that make a line. Okay, so let's discuss this first. A pair means two. Adjacent means next to or touching. So these two angles are touching because they share the common side length here. So adjacent means those two angles not only share a vertex, but also a common side length. Supplementary means adds to 180 degrees. So two angles that add to 180 degrees precisely. And the way that I remember it is it's simply a pair of angles that make a line. So for example, if I were to draw my picture, these might be adjacent angles, but they do not make a line. Here's my line, and if I draw another side length for my angle side, then I know that angle 1 adds with angle 2 to make 180 degrees. This would be an example of a linear pair, a pair of angles that make a line. All right, let's see those examples, those definitions in an example. Example 4 says to use the definitions and decide whether each statement about the diagram is true. Explain your answer using the definitions you have learned. Okay, so it says line AC is perpendicular to line BD. Line AC is perpendicular to line BD. Well, what do you think? Are those perpendicular? We need to look back at the definition. The requirement of perpendicular is that they intersect to make a right angle. Well, they tell us that these two lines intersect to make a right angle there. So yes, we have enough information to say these lines are perpendicular, but we need a because. Because they intersect to form a right angle. Part B says angle AED, and angle BEC are a linear pair. Well, we're talking about this angle and this angle. They both happen to be 90 degrees. We know that much. But are they adjacent angles or not? They are not. So they are supplements. They both add to be 180. But they are not a linear pair because they don't form a line. They are not adjacent. So they are not a linear pair. Since they are not adjacent angles. So when I ask you to explain, I am looking for very big details or very good details so that you're specific and I know exactly what you're implying. All right, go ahead and try the You Try Nows from your packet. The answers should be at the bottom of your handout. Please also make sure your annotations are complete before you come into class tomorrow. And thanks so much for joining me. Have a good day.